Hi, this is David Davis, and I'm honored to be here with the storage legend, Mr. Vaughn Stewart. How you doing, Vaughn?
Hey, thanks for having me. I don't know about legend, but thanks for coming out.
Well, it's great to be here. We're at the headquarters of Pure Storage, and I'm here with the Chief Evangelist of Pure Storage. And so I just want to talk to you a little bit about, Pure Storage, where you guys have come from, and what you're doing today.
Sure. So, Pure Storage, we have a very simple edict and vision, which is to deliver all flash arrays to everyone. Now, I think the market widely recognizes flash as being the most performant form of storage medium. They also recognize it as being the most expensive. And so, through a combination of storage technologies, we take the economic element out of that equation, and we basically propose, if you can have an all-flash array for the price of disk, why wouldn't you? It's more energy efficient, it's more data center friendly in terms of its density in the data center racks itself, and obviously it's addressing the performance challenges not only of today's troubled applications or business processes, but also paves the way for your next set of endeavors, whether it's social, analytical, mobile, or cloud. So that's kind of it in a nutshell. What else can I tell you about?
Well, I think just as a former IT manager and VMware admin, my initial question would be, I'd love to drive a Tesla, but how is that possible? How is it possible to make that something that's so potentially expensive, affordable to the masses of enterprises out there?
Sure, great question. I think the combination of data growth and the way data is accessed today has really put a strain on disk subsystems, and the market by and large has looked as flash as a way to solve this problem. Mm-hmm. And the market by and large is try to cut the cost by and large using flash as a caching tier. Now there are some vendors that have moved into the all flash space, and the early entrants, the ones who had some pretty solid success, said flash is for tier 0. It's a very small market. It's going to be high performance, performance demanding applications, and you'll pay a price premium for that. That market is really fading quick because Pure Storage and others are coming to market with an approach that says you can have economically priced all flash arrays that deliver on the performance promise of flash by reducing the cost. And the way that you reduce the cost is primarily based on data reduction technologies. We here at Pure Storage offer 5 data reduction technologies. 4 of them are inline and 1 is post-process. So the first is inline data deduplication and followed by compression, as well as inline pattern removal and zero removal. Now, the last 2 you may say, those sound a lot like deduplication. What's the difference? Well, compression is byte level, right? It's storing data in a denser format than its native format. Okay. That means if the host is trying to send me a megabyte of data, maybe I can store it in a size that's 500 kilobytes, right? I'm reducing that size. Deduplication is saying, hey, any block data that I have written on disk, or block data written on flash, don't store it a second time, just make another reference pointer to it, right? So we can actually reduce the amount of data that actually has to come from the host down to flash through compression and deduplication, 2 different formats of reducing data set. The inline zero and pattern removal is actually reading the data that's coming in from the host as it's hitting the NVRAM, but before it gets to flash, where we're recognizing these patterns without actually having to look at a hash table and actually dropping the redundancies right out of NVRAM before we go down to flash. Now, I did say there was a 5th, right, and a post-process data reduction technology, which is a second form of compression. It's a more aggressive form of compression, and we apply that during a phase within the flash care or the maintenance of the solid-state drives called garbage collection, right? Hopefully we'll cover during your time here, how you have to treat flash media. It's quite different than disk. And for some of you who maybe aren't familiar, basically you can write to any cell in a flash, but when you erase on a group of cells that's called a page, or some refer to it as a block. And that process of actually having to reclaim pages to write to means you're going to move some of the valid data from cells to a different cell, and in that process of when we actually do that, we actually apply a second set of compression to even reduce the data further. So those 5 technologies combined with the fact that we use MLC and not SLC media allow us to drive down the cost of an all-flash array to that equal to, and in many cases less than, spinning disk. We are averaging globally greater than 6-to-1 data reduction. That global average does wane a bit depending on your application type. Applications like databases, usually 2 to 4x. Those databases don't deduplicate well, so most of the savings from compression. On the other end, where you see a lot of dedupe savings, is any type of workload where the data set is replicated, VDI, or say a database environment where you're making lots of copies of the database for test and dev, QA, right, other forms of testing before you promote something into production. In that space, you're seeing greater than 10 to 1.
Okay.
The sweet spot in the middle between 5 to 1 and 9 to 1 is where we see like virtual infrastructures. I've got lots of deduplication savings because of the redundancy of operating system and application binaries, but those virtual machines run applications and applications compress. So what we really think we've done that's very different than the rest of the flash industry is created an all-flash array that not only breaks the economic barrier, but breaks it in almost in a universal means. We can address a wide range of what I'll call tier 1 workloads.
Okay. So by using that data reduction and by using SLC, or MLC, which is the least expensive of the SSD technologies that are available,
right,
you're able to, as you said, give enterprises an all-flash array similar to the price of magnetic disk.
Absolutely.
Okay.
Now, obviously, for sake of time, there's a lot more that we can explain, and we've got a number of folks that are going to be on videos that are going to go a little bit deeper into this. But for the elements that we've left off, your viewers should stop by purestorage.com, and you can catch up on the details that we've left out of this conversation.
Excellent. So one last question before we go, and that is, what's next for Pure?
So obviously, I can't give you a roadmap here. We can't do a global NDA with your audience, but I would share with it this way, which is we have a view of taking customers to an all-flash data center, right? A flash-fueled economy, if you will. And so how most customers tend to embrace flash today is very tactical, right? I want to put out the fire of some application that I have in-house today, address the scaling of the performance issues. Quickly the benefits of flash become observable, and flash becomes strategic, right? And that wave of strategic is usually through the tier 1 applications today, or the emerging applications, right? The next set of tools that a business will bring online, whether it's social, mobile, analytical, cloud, right? That's a kind of common set of CIO objectives today. That's the phase that we're in today as we acquire customers, in the phase that our customer accounts are going to grow for the next 2 or 3 years. During that time frame, the flash and the NAND industry are going to continue to make denser chipsets, right? Technology will continue to evolve, so we'll get greater densities in the chipsets. The manufacturing volumes will go up, so the prices will continue to drop. We will see new technologies come on board that actually increase the performance of the flash, right? As we move from flash that's connected through backwards compatible disk interconnects like SAS and start to move to only flash interconnects like NVMe, as well as we look at flash vendors stop using carriers based for and architectural designs, hardware designs based for disk drives, again, backwards compatible, and look to architectures that are designed for flash and can really leverage the density of flash. I think all of those technologies come together to continue to drive that price point down. And as that price point continues to go down and get enhanced through software capabilities like Pure Storage has, it's inevitable that tier 2 storage will come. But again, you're talking 3 to 5 years out.
Yeah. So I mean, right now, flash is really being used by more and more consumers today. Laptops, iPhones, everything like that. So, in the enterprise, as I understand, or as I've learned here, it's starting out at tier 1 for the larger enterprises and specialized applications. But over time, it's going to come down and become more affordable and common in medium-sized data centers.
Yeah, I would just, as we wrap up, I would say, the specialized applications, the tier 0 world, I think that's past. We are focused on a total addressable market of tier 1 storage.
Okay.
It's a $15 billion market. Now, you're not going to find the entire storage industry agreeing with us, because if you sell a disk-based array, you're going to say, I've got some disk-based or sprinkle some flash in on that solution to solve it for you. But give us a call. You'd be surprised at what we can help you with if you have a tier 1 type of application.
Okay, so the message is, if you think that flash storage is going to be too expensive for you, give us a shot. Check us out.
We provide all flash for the price of disk. If you can have all flash, why wouldn't you?
Right. All right, well, thanks for your time today, Vaughn. Appreciate it.
Thanks for coming out.